All right, so welcome to section 5.4, more trigonometric functions. So you can see I have a picture of the unit circle here. Although I put R for the radius here, you can see that there's a 1 on the y-axis and a -1 over here on the x-axis. So I actually have a circle of radius 1 here. And we talked about the basic, we have a homework question. Okay, we'll come back to that in just a few minutes, Daniel. Let's see, where was I? Oh, we talked about the basic trigonometric functions the other day, so I just want to review those, and then we're going to look at some other trigonometric functions and see how Daniel's question fits in. All right, so we talked about the sine function the other day, and we defined the sine function as depending on an angle, and we abbreviate it just SIN. And the sine depends on some angle. So we need an angle to work with. And the sine is defined on the unit circle to be related to the y value of a point. It also depends on the radius. So the basic definition is that on a general circle, it is the y value divided by the radius. If we happen to be on the unit circle, unit, right? Remember, that means radius equals 1. So on the unit circle, the sine is just straightforward. It is just the y value, right? Dividing by 1, not too exciting. We got this other function called the cosine function. And co means like it's a partner to the sine. And the cosine was defined, my pen's glitching there. The cosine is defined by, it has to have an angle. It's worthless without an angle. And it is defined to be the x value divided by the radius on any circle. If we happen to be on the unit circle, then that means we're dividing by a 1 there, which is kind of boring. Dividing by 1, nothing happens, and we just get the straight off x value from the cosine. Okay, so those are the basic definitions we worked on before, and then we played around with some special angles coming around. And I asked that you memorize the first quadrant of the unit circle. So let's review that quick. So you definitely want to write this down yourself every day until you have it committed to memory, and you can just spit this out off the top of your head. So here, I'm going to draw the first quadrant of the unit circle. So that's x equals 1, y equals 1. And our special angles are 0 radians, pi over 6 radians. Oops, that is not a pen. Let's pull out a different color here. Through the middle here, around there, we have pi over 4 radians. And then pi over 3 radians is about there. And again, the pi over 6, pi over 4, pi over 3 are related to degrees, 30, 45, and 60. I need you to know the radians. And then up at the top here, the angle that makes a right angle is also pi over 2 radians. Now, for any point on here, and these angles identify 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5 points, you need to know those coordinates. So down here, the point is x equals 1, y equals 0. Here, the point is x equals square root of 3 over 2, y equals 1/2. Here, most common way to write it is x is square root of 2 over 2, y is square root of 2 over 2. And up here at pi over 3, we have the point 1/2 for x. And if you look, like if you trace that down, right, you can see it hits at about 1/2 if I drew my picture well. And then the y value is the square root of 3 over 2. Right, the flip of this point down here, and then up here we finally get x equals 0, y equals 1. Now remember, on the unit circle, x and y, the points we have there are also the cosine of the angle, comma sine of the angle. So knowing this unit circle and knowing that the x value is the cosine and the y value of the sine tells you that if you're asked, well, what is the sine of pi over 3, you would say, oh, it would be the square root of 3 over 2 because that's the y value of this point. So you've got to memorize this. Alternate way to display the information in this picture is in a table I presented last time, where we consider the angle, cosine, and the sine. So let's look at that again. And again, you should write this down daily till you commit it to memory. So given one of those special angles in the first quadrant, you need to know what is the cosine of that angle off the top of your head. You need to know what is the sine of that angle off the top of your head. Our angles are 0, pi over 6, pi over 4, pi over 3, pi over 2. And remember, those are related to the degrees. 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Green numbers are in radians. So often we will not write the word RAD, the phrase RAD for radians. If you don't see a unit, that means it is radians. That's the convention in trigonometry. So what is the cosine of 0? Cosine's an x value, it must be 1. What is the cosine of pi over 6? Pi over 6 is the x value, so it must be the square root of 3 over 2. At 45 degrees, pi over 4, x and y are the same. X value at pi over 3, 60 degrees, we can see here is 1/2. And we'll check these on the calculator in just a sec to make sure. And then again, these values are dropping. So 1, this is 0.8-ish, this is about 0.7, about 0.5, and then we hit 0 there. Right? So as the angle increases here, the x value is dropping in the first quadrant. Sine goes the other way. Sine of 0 degrees or 0 radians is 0. The sine of pi over 6 is 1/2. Right? See the symmetry in this chart here? Square root of 2 over 2, square root of 3 over 2, and then 1. So let's confirm one of these on a calculator just for fun. I'm going to whip out the Desmos calculator here and use the graphing version. So on my picture, right, I claimed that the y value at pi over 3 is square root of 3 over 2. So the sine of pi over 3 should be equal to square root of 3 over 2. Let's see if Desmos agrees with that. So I enter what is the sine of pi, and you can just type pi and it will whip out pi over 3. And I get the value, these parentheses are in the wrong spot. I get the value 0.8666 or 0.866. Let's check, is that really the same thing as the SQRT of 3 and then divided by 2? And I can see, yep, they're the same number. So although you can get approximations on calculators, you can't get exact values, you have to know them somehow. And we did a little geometry a couple classes ago to figure out that the sine of pi over 3 was the square root of 3 over 2. If you're not used to the shortcuts like typing pi to get pi or SQRT to get the square root, right? In Desmos, you have this toolbar down here to get those keys. And if you have Desmos on your phone, then those keys are just right in front of you when you click on a box. So you got to learn how to use your calculator well for this class. Very important. All right, so what we're going to do next is we're just going to add some trig functions because there's more than just the sine and the cosine. So I'm going to go back here and I'm going to define a new function, the tangent function. And the sine, cosine, and the tangent function are the most important ones. And there's 3 other ones we'll get to a little later. So the tangent function is defined in a couple of different ways. On the circle, the tangent is the ratio of the 2 points. So the x and the y value. So the tangent of the angle right? So whatever angle I have here, theta, it looks like theta is around 30 degrees-ish here. No, it's not. It is maybe mid-30s, is defined to be the y value divided by the x value. And if you think about that for a second on the picture here, if I take the y value here and I divide by the x value here, what I'm getting is the slope of this line that the angle makes. So another way to think about the tangent function, the tangent converts angles to slopes, which is kind of cool. All right, so in this case, just a cool side note, on the circle here, y over x is the slope of the radius. All right, so what that means, the deep meaning, is that the tangent converts an angle into a slope. Right, so super easy version of that one right there. If you think about the first quadrant for a second, and then I throw in that angle right there, and I am attempting to draw the angle pi over 4 radians. And pi over 4 radians, recall, is the same thing as 45 degrees. And at 45 degrees or pi over 4, what's happening is as I go over some amount x, and then I go up y, this is the line y equals x, right? What's the slope of this line? Well, the slope is 1. So that tells me that the tangent of 45 degrees or pi over 4 radians ought to be 1 because that's the slope of this line, right? So that gives us the slope of a line. Another example. Let's consider this one right there, and that, to the best of my artistic ability, is pi over 3 radians. Pi over 3 radians is equal to 60 degrees. And on the unit circle, if this were the unit circle, let's throw in a circle here. Boom. This point right here, y is bigger than x is. X should be about a half. If I drew my picture right, should be the point 1/2 square root of 3 over 2, a point you need to memorize. So the slope here, m, ought to be the square root of 3 over 2 divided by 1/2. The halves conveniently divide out, and so the slope there ought to be the square root of 3. Now, if that's the slope, then the tangent of pi over 3 should be that slope, square root of 3. Let's check it out on a calculator. There's my calculator. So ask Desmos, hey Desmos, what is the tangent of pi over 3? And you should close parentheses, even though it calculates before I've even closed. All right, let's compare that to the square root, which you can type SQRT or get the cute little button down here, 3, and check it out. They are one and the same. Tangent converts angles to slopes. That's what it does. Another way to think about tangent is, again, any point I pick, that one right there. If I'm on the unit circle, that point is the cosine of the angle. So that would be the cosine of pi over 3. That's the 1/2. And the square root of 3 over 2 would have to be the sine of pi over 3. So if I know that the tangent of an angle on the unit circle is the y value over the x value, I also know the y value is the sine of the angle and the x value is the cosine. So this is an important relationship here, that the tangent of an angle is also equal to the ratio of the sine of the angle divided by the cosine of the angle. This is super important fact here. Important. All right, so that's the intro to section 5.4. We'll do some more with this and look at some other trig functions very soon.